Hello students, now so we'll discuss the purification of organic compounds. Purification of organic compounds. It is the most important topic in chemistry. Like we can say every year at least one question is framing on this particular topic. Now this particular topic today I am going to discuss the question which already framed in NEET 2025. NEET 2025, one question came on the purification of organic compound. For that question basis, I am going to discuss the four different types of purification of organic compounds. Now, let us see one by one. Now, here first one, what we discuss here is first one, simple distillation. Simple distillation, what we have, simple distillation here you can see there. So, the basic, first we'll see what is the meaning of, what is the definition of simple distillation. So you can see here, simple distillation is a technique used to separate the components from liquid mixture based on their difference in boiling points. Right? So that means what happen? If I want to separate the two liquids, that means what we have? We should have the difference in their boiling point. We should have, let us say here, let me take A, one liquid, B, another liquid you have taken. That means what happen? The boiling point of the boiling point of A is not equal to boiling point of B. Right? This is the condition, the meaning, right? So now the two liquids must have significant difference in their boiling point. What does it mean that? So suppose let us say we'll take A liquid we have taken, its boiling point will be, let us keep it as a, so 25 degrees Celsius. Now, if I take another component, another liquid, that is a boiling point, B, the boiling point of B will be, let us take it as a around, so 70 degrees Celsius, right? Now, if I take these two liquids, so now what happen? When I start boiling these two liquids, when I start boiling these two liquids, let us when we start boiling these two liquids, what happen? So here liquid A, liquid B we have taken. Assume that A becomes red, A becomes the red line and B becomes the blue liquid. So I have taken the Bunsen burner. Now let me start giving the heat for this both of them. So whenever we start giving the heat, the low temperature in this, which one will be having the low temperature? A will be having, right? So A will start boiling first, where at 25 degrees Celsius itself, A start boiling. That means if A is boiling, it start giving the vapors. When A start boiling, it start vapors are producing. Now what happened? Now these vapors, whatever the vapors formed by A upon giving temperature, this will take into another beaker, will condense the vapor into frame the liquid. That is what the motto of this process will take place here. Now we'll see here one by one, step by step, we'll discuss what actually the process will take place. Now whatever I discuss in this case, no, the same thing will happen in this case. Now see here, first condition what we have, the two liquids must have difference in their boiling points, significant difference. How it works? So it works by heating the liquid mixture until the components with a lower boiling point vaporizes. That's what no here. A is having the low temperature, B is having the high temperature. When we start giving the temperature, the one lower having the temperature, it will start boiling and it converting into vapors. Now, whatever the A is producing the vapors, then that vapors we cool and we condense and we converting into liquid for collection. That is what the simple distillation is. Very easy to understand you, right? Now, here examples, what we can able to see here, examples for this. So here chloroform having the 334 Kelvin temperature, aniline having the boiling point is 357. So this can also be separated by using the simple distillation method. Now ether toluene. So ether having the 308 Kelvin temperature, whereas toluene having the 384. So you can see there each and every case there is a low significant difference in their boiling point. Then we can also see the purification of benzene with the aniline. The benzene having the 353 melting point, boiling point, aniline having the 457. Now, so separation, chloroform low boiling point. So that will boil it low temperature and that will boil first. And it started giving the vapor. That vapors are collected and the one which is having the high temperature which will left out in the liquid state. That means what happened? A is separated in a form of vapor. B is separated as a liquid form. Right? The higher boiling point will be behind in the flask itself. So now we can see how this will take place actually. Now, so here what happened? This NCRT diagram. So here the round bottom plus that what we are discussing. Let us take in this round bottom plus. We have taken two liquids, right? So we have taken two liquids in this. So here A liquid plus B liquid you have taken, right? Now let us say A is equal to boiling point of A will be how much we have taken? 25 degrees Celsius. Whereas B liquid having the boiling point will be how much we have taken? 75 degrees Celsius. Now this both liquids, when we start giving the heat for this liquid, now this liquid start, the one having the lower boiling point which start boiling, which start giving the vapors. It start providing the vapors in the above surface of the liquid. Now these vapors what happen? They pass through like this. Here, now here the condenser is there. It will condense the vapor. Then, so here the liquid is coming. This liquid you can say in this condition is A liquid came out. A is come out as well as B also left out as it is in a liquid form. Why B left out as a liquid form? Because it is a high temperature as compared to the A. Now, so this method can be used for separation of like volatile liquids, separation of volatile liquids from non-volatile liquids. What actually mean by volatile? The compound which will vaporize easily without giving any temperature. That is called as a volatile substance. For example, you can take a petrol. Petrol is a good volatile substance, whereas a water is not the volatile substance. So the liquids having the sufficient difference in boiling points, right? These two cases we can able to use a simple distillation. One will be volatile to non-volatile difference of two components. Another one, the liquids having a significant difference in their boiling point. Now have small recap again. So here simple distillation, what actually meaning is simple distillation is a technique used to separate two components from liquid mixture based on what basic principle is based on the difference in their boiling point. This is a major principle of this one. Now, so mechanism how we'll take the beaker. In the beaker, we have the two liquids. In the two liquids, one liquid having the low temperature, other will be having other will be on the high temperature. Whenever we start boiling, the lower boiling point of liquid easily start to vaporizes that will converting into vapor. That vapors are collected and condensed. That will provide the air separate. And the one high boiling point which will be left out in the solution. That's the first case of simple distillation. Now, now we'll see the case of fractional distillation. Also, we can see fractional distillation. Fractional distillation, here what we have? This one. What is the primary condition for fractional distillation? In this case, also, the boiling point of two liquids is not much difference. The boiling point of two liquids is not much difference. Will be a less difference will be enough. For example, let us say we have taken two liquids here. What two liquids you have taken here? Look at see here. So, so here acetone having the 330 Kelvin, whereas methyl alcohol having the 338 Kelvin. Now, in this case, what we will do, here there is no much difference is there in their boiling point. There is no much difference in their boiling point. Now, what is happening in this case? How to separate? In the previous case, we have lots of differences there, so we can able to separate. Now, in this case, same thing we will take. So here, one flask we have taken. Now, in the flask, we are taking the two liquids, A liquid and B liquid. Let us say that A liquid having the 330 Kelvin temperature and B will be having the 338 Kelvin, right? Now, whenever we start giving some temperature for this, so there is no much differences there for the two components. In that case, what happen? We will use the fractionating column we will use. That is the most important word. You should be aware of that one. So fractionating column we are using in this case. And see here, the vapors of such liquids are formed within the same temperature range or condensed simultaneously. Same temperature or nearly same temperature range, right? Now the vapors of liquid mixture are passed through the fractionating column before condensation, which is fitted over the mouth of the round bottom flask. Okay. Then vapors of liquid with higher boiling point condense first on the cooler surface lower down the column. That means what happened? We'll discuss with the diagram. The vapors of the liquid, the lower boiling point, continue rising until they reach the top, where they condense and collected. Now, fractionating column provide many surfaces. Fractionating column is very important, guys. So, fractionating column, fractionating column provides many surfaces for the heat exchanger between the ascending vapors and descending vapors. Now we'll go to the diagram so then we'll understand. So this is what the fractional distillation equipment we can use here. So right, so here this is the round bottom flask. That in the bottom flask we have taken the two liquids which are having the so small variation in their boiling point. Let us say A we have taken, B we have taken two liquids. Right? Now here the Bunsen burner we are giving the heat. Now let us see here this one. This is called as a fractionating column. We can say that these are the called as a glass beads. Glass beads. Okay. Now these glass beads having the each having the good surface area. So what is the use of surface area in this case? Now we'll see. Now when we start heating the this particular two liquids, the one which is having the low temperature, let us take A we have taken, B we have taken, right? So here, let us say A is the lower boiling point liquid, B is the little bit of higher boiling point liquid. Got it? Now, whenever we start heating this one, lower boiling point, higher boiling point, there is small differences there. There is not much differences there in the boiling point, right? Now, the one having the lower boiling point first vaporizes, start coming the vapors here, like this vapors will come. Along with that, in that B also vapors are available. Why B is coming? Because A and B are not high difference there. Right. Now, so now here the use of fractionating column will come into the picture. Now, both are vaporizes, both are gases. Now, which one has to move higher? Which one has to tackle this one? Like I said, it's a kind of a speed breaker. This kind of a speed breaker. So the vapor which is passing this speed breaker will be going to the out of the this container. Then how it vary and that how can able to see here the funda will come in. Kinetic energy will come. What is the kinetic energy that will try to produce during the motion of the object only, no? So now A having B having two liquids, they have vapors, we have. Now, as we increase the temperature, A forming little bit of higher vapors than B due to slightly low temperature, right? Now, along with that, as this having the high low boiling point, this person having the high kinetic energy, A will be having the kinetic energy of A is more than kinetic energy of B. Absolutely correct only, no? Right? Yes. Now, the one which is having the high kinetic energy, which will tackle this speed breaker, then which will go to here, then we can able to condense here. That will be coming here. In the previous case, what happened? So we have large difference in A and B liquids. So we no longer require the glass bits. But here glass bits required. Both are, let us take an example what we have. So here X person is there, Y person is there. Both are both are running having the running race. Right? Both are in a running race. Now X person got so like very smooth road to run. Y person got just like like this kind of speed breaker up and down the body. Now, first case what happened? So let us take this y x person also will be having the same. Now let us say this person having the same energy and initially this person also having the same energy, right? Now when they start running in a running race, the one which he is carrying the energy more as compared to this one person, other person that can only reach the destination only. No, let us say here initially little bit of them the same energy, same or nearly same. When they start running race, so the one will be higher energy. That person can able to reach the destination very fastly compared to second person. That is same panda happening here. Now, so here the liquid having the high kinetic energy that will tackle up, it will be reaches to the here we can condense the vapors under the liquid. Right. Now here can say here simple packed column. Though these are the glass bead. Different types of glass beads we can use here. So here also bubble plate column. So what happen now? The vapor will come like this. They have to tackle like this. So like this, they have to tackle like this. The one which can able to tackle the speed breaker, then kind of a speed breaker. The one which can able to tackle speed breaker easily, that will be went out of the container. So this how we can able to separate the using the fractional distillation of the fractionating beads. Right? In this case, what are the examples? So now we can come to one more time here. Each successive condensation and vaporization and unit in the fractionating column is called as theoretical plate. So we have to do number of times to purify the two liquids. Why? They have small difference in the boiling point. So we need to do multiple times only, no? At a time if I do, how I'll get? I cannot able to get the purify, right? Now, so fractional distillation use it to separate fraction of crude oil in petroleum industry. This is very important. Examples is very important. This one, right? Now, examples particularly here, acetone can see there 330 Kelvin temperature, methyl alcohol 338. So there is only 8 Kelvin temperature variation is there. We can also use for benzene as well as toluene. So guys, so this is a fractional distillation. Now we'll go to the, I hope you understand, right? Now we'll go to the distillation under reduced pressure. Distillation under reduced pressure. Now distillation under reduced pressure, why we, what is the process we'll discuss? Distillation under reduced pressure. So what is the primary condition for this? Primary condition for this particular process? Got it. This method is used to purify when it has higher boiling liquids. That means what happened? It is used to purify the liquids that have very high boiling point. Okay, right? Now, for heat sensitive liquids, sir, what exactly mean by heat sensitive liquid? Heat sensitive liquid is nothing but, suppose, let us say, I have taken XY compound, XY compound I have taken. Now, for this compound, when I start giving slightly temperature, it is dissociating easily. Dissociating easily. This is called as a sensitive, heat sensitive. Right? The compound should not decompose or dissociate upon giving temperature. Here we are separating now. We are not dissociating. So in that case, what happens? The compounds having the I have compound like having the high boiling point, but along with that, it is a heat sensitive. That means what happens? It is essential for liquids that tend to decompose or break down at or below the normal boiling point when heated. That will break out easily, normal boiling point or below or above. Those we are calling as heat sensitive. So whenever these two cases are there, we can use the reduced under a reduced distillation method. This one. Okay. Heat sensitive liquids as well as high boiling liquids. This one. Okay. Now we'll see how the process takes place. Those liquids which are made to boil at a temperature lower than the normal boiling points. So how it is possible? They are having the normal boiling point. We are making them to boil at low temperature. How it is taking place? This is the condition here. Reducing pressure on the surface. How the pressure is reduced? We'll see that one. So here, see, pressure reduces itself. No, how the pressure will be reduced. See, what is the pressure? Will be having the pressure is proportional to the number of gas molecule, right? So if I reduce the gas molecules, if I remove the gases, if gases reduces by using the vacuum, then the gas molecules are reduces. That means what happen? Pressure also reduces only, no? Pressure also reduces. If pressure reduces, automatically my boiling temperature also reduces. That's what you know. PV is proportional to PV is equal to nRT only, no? PV is equal to nRT only, no? Right? So here what happened? We are decreasing the number of moles of gas, pressure decreasing, pressure decreases, pressure also decreases. So the funda is very clear. What is exactly meaning of reduced pressure under? That means if you are any compound having the high boiling point, but it's sensitive. In that case, we have to use this kind of situation. Now we'll try to clear out clearly. So here two liquids are made to boil at temperature lower than their normal boiling point by reducing the pressure on the surface. Right? So a liquid boils at a temperature at which its vapor pressure equal to the external pressure. Vapor pressure equal to the external pressure. Okay. Now the pressure is reduced to with the help of water pump or you can say vacuum pump that I told you here. No? So we have to use the vacuum pump to reduce the number of gas molecules. As a result, pressure decreases. Pressure decreases, obviously temperature also decreases. Now we'll see diagrammatically how it takes place here. So here, point to point, we'll try to understand, right? So first, what we have taken? We have taken the a flask, right? So here in this flask, we have taken two liquids, A plus B, two liquids we have taken. Okay. Now, whenever we start heating the liquids, so we will it start vaporizing, right? So now what happened? What the condition we have? So heat sensitive substance, heat sensitive compounds, if I available. Heat sensitive means they will decompose at normal boiling point or below. Now, for that, what we are doing before that, we are using the low. You can see here vacuum pump. This vacuum pump is what happen. It's sucking all the gases. That is what happen. So it will be removing the gases pressure. Yes. So pressure decreases as well as temperature also decreases. As temperature decreases, now what happen? We are controlling or protecting the heat sensitive of the particular component by reducing the temperature. Again, when we decrease the temperature, that means what happens? It cannot able to decompose, right? Now, so now we can start giving the vapors, right? When we start giving the temperature, so A will go here, it start boiling the vapors. Keep in mind, the compound should not be dissociated. For that reason, we use a vacuum pump to reduce the temperature. So we cannot able to see the decomposition there. So the vapors are coming. So vapors are coming here, coming. So we can able to use the distillation water liquid, right? Distillation under reduced pressure. A liquid boils at a temperature below or its vapor pressure by reducing the pressure. Simple thing is the liquids having the high boiling point, high boiling point, first condition. Next condition, heat sensitive. Heat sensitive. For this heat sensitive, we are reducing the pressure. When we reduce the pressure, automatically temperature decreases. So we can able to separate the two liquids. In this case, what we can able to use examples here. So glycerol can be separated. Glycerol can be separated. Glycerol can glycerol can be separated from the spent lye in a soap industry, guys. This is the only question has been framed in the NEET 2025 spent lye in soap industry using the this technique. We can use the glycerine, peroxide, formaldehyde are purified by vacuum distillation method. This is also called as a vacuum distillation. We are using the vacuum pump to reduce the pressure. To reduce the pressure for what? To decrease the temperature. To decrease the temperature for what? To not decompose the compound. Right? So I hope this will be clear, right? Now we'll go to the next one. This will be steam distillation method. So different topics are there. It is very easy for you guys to understand here. Steam distillation method, what will happen? Steam distillation method. So here, this technique, what is the purpose of this technique? Will you see, right? What is the purpose of this technique? So here, this technique is applied to separate substances which are steam volatile. What is mean by steam volatile? That means what happened by giving the steam to the liquid, it started vaporizing with respect to steam itself, not even temperature. Steam will be having the kind of high temperature vapor, you can say, right? Hmm. Now immiscible with the water. That means what happened? The substance should not dissolve into the water. The substance, the one which are going to be separate organic compound, insoluble. Immiscible, nothing but will be not dissolved. Now, third condition, what we have? Third condition, what we have? So, process having the high pressure condition, like a 10 to 15 mm of Hg at 373 Kelvin temperature. Now, fourth condition, what we have? It contain non-volatile impurities. So, guys, non-volatile impurities, what happened? This person will not going to be vaporized, easily separated from the liquid mixture. Next, what happened? Steam from the steam generator is passed through a heated flask. Steam now what we did? We are giving the with respect temperature. Now in this case, what happened? Heat flask. From the heat flask, we are passing the steam itself. Not even temperature. Now, the heat flask contains the liquid to be distilled. What? Repeat once again. So, steam from a steam generator is passed through a heated flask containing the liquid to be distilled. Now, the mixture of steam and the volatile organic compound is condensed and collected. Okay, so here what happened? Simple. Funda is not the difficulty here. What is a funda is happening here? So, one second, guys. Yeah. So here, let me take the liquid in this. A, B liquid we have taken. Okay. Now, this liquid should be steam volatile, primary condition, immiscible with the water, having a high pressure, high temperature, and should contain non-volatile chemicals. Now, for this, what we are doing, we are passing the steam through this. Means we are sending the steam we are sending here, steam, right? Now, steam is nothing but a vapor form, high temperature, vapor form. Okay. Now, whenever we pass the steam on this, with respect to the steam, the liquids which will start vaporizing, again, the vapors will be what happen? We will separately take and will condense that one. It will be forming as a liquid. The simple thing, nothing is there. I'll repeat one more time. Don't worry. We have taken two liquids, AB. Okay. Now, for this AB, we are passing the steam, which is high temperature of vapor. Now, when we pass the steam, because of the steam, this liquid start boiling. One will boil. That means non-volatile liquid will not boil. Whereas a volatile will be boil, will be vapor will form. That vapors are collected and will condense this one, will fill the liquid. That is what will take place here. Right? Now, now what happened? We'll see some more point here. So here the compound is later separated from the water using the separate funnel. This is what only know. Here we got it right. In a steam distillation, the liquid boils when the sum of vapor's pressure due to the organic liquid P1 due to the water P2 becomes equal to the atmospheric pressure. That means what happened here? So simple meaning is here. So here, let us say here P1 P1 of organic compound, P2 of water vapor. That we are using steam now, water vapor. Suppose, let us say external pressure will be having the 760 mm. Okay, external pressure is 760 mm we have. Else we can take not that much. We can take, let us say external pressure is around so 12 mm of Hg we have. Now, if I add this one is 6, if I will be 6 mm, this become so 5 mm, or you can say yes 6 mm. So what happened now? 6 plus 6 become 12. That's what the point of meaning here. No? In steam distillation, the liquid boils when the sum of vapor pressure is due to the organic liquid and due to the water vapor becomes equal to the atmosphere. Then only this is the condition. In this condition only, it will boil out. So P1 is a lower pressure. The organic liquid vaporizes at low temperature. Now here you can say you can take here, you can take the pressure of this particular one. You can take 3 mm, this will be 6 mm. Or you can say here, this is 9 mm. Now water vapor will be high pressure, is low pressure. So low pressure one easily vaporizes. We can collect at the condensed water. Now, the mixture of water and the substance is obtained, which can be separated by using separating funnel. So here, in this case, which one we can able to separate here? This one. Aniline can be separated by this technique from aniline water mixture. Now we'll try to see the diagrammatically how the process will take place. Okay. So this is the round bottom flask. So here the temperature is there. Right. Now here we have taken the let us say here water we have taken. Right. So this is the water we have taken. This organic compound. This organic compound. Right. Now for this water we are giving the heat. So vapors are coming here. These vapors are coming. The vapors are falling on the surface of the organic compound. Now, because of these vapors, this organic compound start vaporizing. Again, these vapors what happen? They can go to in this beaker will be like this. So here condensing takes place. Now become forming as a liquid. Now see here, water separated, liquid separated. That's what the condition is immiscible. Immiscible with water. Immiscible with the water. Not dissolving. Not dissolving. So water is outside above the liquid of the organic compound. So here what happened? Let us take here clearly one more time. Small recap for this. So we have taken organic compound liquid A and let us say B due to the water. Okay. Now from the organic compound we have some impurities also. We don't want the impurities. We want only pure organic. So what I will do? I will take this one. Let us say pressure of this one is 20 mm and pressure of this one is let us say so 50 mm FSG, right? Water vapor pressure. Now, so whenever this water vapor is falling onto the organic compound, this below easily vaporizes. When this is vaporizes, along this vapors, they combine, they start moving out of the container. Now, when they are coming here, so water is falling separately and organic compound is falling separately. So that means what happened? We can able to separate easily. This condition, primary condition of say no, they should be immiscible with the water. Does not dissolve. Does not dissolve. Both water and organic compound. That's the primary condition. So, right, steam distillation, steam volatile components volatilizes the vapors condensed in the condenser and liquid collected the conical flask. So, that is what is the steam distillation. Using the steam, we have to separate this. Now, here, this is the point that will be asked in the exam. Which point? The aniline. Aniline can be separated by this technique from the aniline water mixture. Yes. Okay. Okay, so guys, I think clear, right? If any doubts are there, you can comment to me. Okay. Now we'll see the question which is asked in our NEET 2025 exam. So, right, you can see here, match the match the following. So match the following the given. So here, whatever we discuss here now, the four process, I have taken the four process based on this question itself. Now here, fractional distillation is there, simple distillation is there, steam distillation is there, distillation under reduced pressure. Okay. Now, first one what happened? First we discuss simple distillation. No? Simple distillation. What we got there? So they should have the large boiling point in difference. No, large boiling point difference. Here what we have? So you can see here chloroform as well as aniline comes under simple distillation method, right? Chloroform as well as this is chloroform as well as aniline. So A becomes fourth. A becomes fourth one, right? Now next what we discuss here, fractional distillation. Fractional distillation what happened? AB is nearly same. Let us say this is a 330 This become 380 Kelvin temperature of boiling point. In this case, what happen? If it is 200 Kelvin temperature becomes 500 Kelvin temperature. Last difference in the boiling point. So here fractional distillation. So what we used here, can take an example directly. So fractional distillation. You can see here, fractional distillation is to separate the crude oil in petroleum industry. Guys, the example is also very important. Acetone, methyl alcohol, benzene, toluene. So in this question, given one is crude oil in petroleum industry. That means P goes to fractional distillation. Now, then after what we discussed here, distillation under reduced pressure. This will be used for the compound having the heat sensitive high boiling point. High boiling. Okay. That what we have used here. I think we have used the let us say spent lye. Right? No. Distillation under reduced pressure is spent lye in soap industry. Or this examples also keep in mind. So every year question is making we should be very aware of. Glycerin peroxide, formaldehyde under then in this reduced pressure. So here this glycerol from spenduli goes to the reduced pressure. The last one aniline water will be goes to the here steam distillation. In the steam distillation, so we will take water steam as well as organic compound liquid we are separating. This pressure will be is more than this pressure, right? P1 is more than P2. Then the sum P total pressure, external pressure must be equal to the P1 plus P2. Then only it start vaporizing. So what we have A4. So two options eliminated A4. Then B3. B3 we have both cases. Then we have C1. C1 we have then D2. So the right answer for this very is 1. So the question is here. In this case, nothing will be difficulty. Very easy. That is what actually I made this one for you. So you guys just go through this one. I'll upload this PDF in the description link. You can take this one and remaining topics I will discuss, right? So with respect to your comments. Okay. Now, okay. So thank you guys.